All right, let's do a regression problem here. This is chapter 9, statistics, linear regression. We're going to do three things. We're going to see if there's a relationship between the x-coordinate and the y-coordinate. We're going to do a hypothesis test on that. Then we're going to find the linear relationship, so find the line of best fit. And then we're going to come up with a prediction interval for a particular x value around our regression line. So let's start out by plotting the points. So 0, this is the x, is the number of dates, and hours is the y variable. So 0 and 3 would be up here. So plot all your points. I put little triangles for my dots. 1, 3 would be here. 2, 2 would be right here. 4, 1 would be over here. 3, 0 would be right here. And 4, 0 would be right here. Okay, so it looks like there might be some kind of a relationship between x and y, and we're going to do a statistical test to see if there is. So our hypothesis is going to be rho, and that's the population correlation coefficient, looks like an upside down 6, equals 0. That means there is no relationship. And rho does not equal 0, means that there is a relationship, a linear relationship between x and y. So as soon as I write the alternate hypothesis, I'm going to write my conclusion. It's always based on the alternate hypothesis. And I can or cannot be 95% confident that dates in a week and hours studying, that dates and hours studying are linearly related or linearly correlated. Okay, so that is the alternate hypothesis. Rho does not equal 0 means that they are linearly correlated. So that's kind of a weird thing. Not equal 0 means that there is a linear correlation. So you got to remember that. Okay, the critical value. Well, let's do step 3 first, and I'll come back and do step 2 because it kind of depends on a little bit what's going on. So to do step 3, we need first off to figure out the correlation coefficient, and it's a pretty complicated formula. It's n times the sum of the xy's minus the sum of the x's times the sum of the y's, all divided by a big square root of n times the sum of the x squareds minus the sum of the x's quantity squared, times the same thing for the y's, n times the sum of the y squareds minus the sum of the y's quantity squared. So we're going to find out 3 numbers here. We're going to find out the numerator and the 2 factors in the denominator. So we've got to add up all these columns. You know, every sum, every sigma in our formula, we need a column of that. So I've got an xy, an x, a y, an x squared, and a y squared. So I'm going to put an xy up here right in the middle, a y squared over here, an x squared over here. We're going to fill up every one of those columns, add them all up, plug the numbers into this formula, and we'll have an answer. So x squared is going to be 0, 1, 4, 16, 9, 16. That's a 4. XY is going to be 0, 3, 4, 4, 0, 0. Now y squared is going to be 9, 9, 4, 1, 0, 0. And all this formula does is it magically comes up with a number between +1 and -1. +1 is the dots all fall on a straight line with positive slope. -1 means our data points. These data points here all fall on a line, perfectly on a line with slope negative. And obviously, the correlation coefficient is going to be somewhere between +1 and -1. If it's close to 0, that means there's not really a correlation. Okay, so this formula magically does that. Let's add up all these numbers. So it's going to be 32, 42, and 4 is 46. That's the sum of the x squareds. This is going to be 8, 12, 14 is the sum of the x's. This is going to be 8 and 3 is 11. That's the sum of the xy's. The sum of the y's is going to be 6, 9. The sum of the y squareds is going to be 18, 22, 23. And then we plug them into this formula. And I get n, by the way, is how many dots are there on the graph. N is 6 because there's 6 dots on our graph. Okay, so that's our sample size, 6 data points on the graph. So this is going to be 6 times 11 minus 14 times 9. That's the numerator. The denominator is going to be 6 times 46 minus 14 squared. That's the first factor in the denominator. The second factor is going to be 6 times 23, sum of the y squareds, minus the sum of the y's quantity squared, so minus 9 squared. And you're going to figure out what those three numbers are, and then you're going to come up with the whole answer there. So let me do that. The denominator, 6 times 46 minus 14 squared is 80. So this number in the denominator is 80. 6 times 23 minus 9 squared is 57. And the numerator, 6 times 11 minus 14 times 9 is negative 60. So this is negative 60 over the square root of 80 times 57. And you need to write those numbers down because you're going to use them later. So let me figure out what that is. 80 times 57, take the square root of that, and 60 divided by that, I'm going to put that in memory, is negative 0.8885. So you can see that's pretty close to -1 because the data falls pretty much close to a line with negative slope, so negative 0.88. Now, once you get that, you're going to take that and put it into the second part of the equation, and that's the t equation, which is r over the square root of 1 minus r squared over n minus 2. And that's going to give us our t, and that is step 3. So it's going to go right in here. Okay? So the way you do that, and I would recommend you do it like this. Let me write it up at the top. This is where most people make the mistake in doing this calculation for step 3, doing that equation right there. So watch what I'm going to do, and you write this on your formula sheet. I'm going to type into my calculator, I'm going to type in answer divided by square root, left parentheses twice, 1 minus answer squared, close parentheses, divided by n minus 2. And n minus 2, I can do in my head, is going to be 6 minus 2 is 4. So in this case, it's going to be divided by 4. Okay, so you have that correlation coefficient in your calculator. Don't hit clear. Just type this into your calculator. Answer divided by square root, left parentheses, 1 minus answer squared, close parentheses, divided by 4, close parentheses again. And when you do that, I get 3.87. Now you have to remember that it was negative r, so it's going to be negative 3.87. Okay, and it's negative because the slope is going down. It's negative slope, right? So that's step 3, negative 3.87. Okay, step 2 is going to be find the critical value. It's going to be a t-test. This is a t, formula for t. These formulas, by the way, are at the top of your formula sheet. They're the ones right up here at the very top. So here's the formula for correlation coefficient. Right next to it is the formula for t. So once you find the correlation coefficient, you put that into the t formula for r, and it gives you a step 3, our data is t. Okay? All right, now the critical t is going to be, we want it at 95%. It's going to be a two-tailed test, always two-tailed in hypothesis testing for correlation. So in this book, we always do a two-tailed test. So this is always a not equal, an equal and a not equal. So this is the hypotheses for every single problem that we do in this class on correlation. It's going to be that exact same thing. And you do have to write it exactly like that. Right? I will take points off if you don't write it exactly like that. It's got to be rho equals 0, rho does not equal 0. You got to know at least how to make a reasonable looking rho. Okay, so what's our data's t going to be? Well, it's going to be a two-tailed t-test. Let me do it up here at the top. I've got 95% in the middle, so 0.025 in each tail. Right? And this is weird. This is different. On your formula sheet over here, the very right-hand corner, if you look at that second line, it'll tell you what the degrees of freedom is. The degrees of freedom is n minus 2. And that's because, you know, you've got two variables here. I've got an x and a y. So degrees of freedom is no longer n minus 1. For correlation, it's n minus 2. Circle that, highlight it. Don't forget that. It's on your formula sheet. So I've got degrees of freedom. 6 minus 2 equals 4. So 4 degrees of freedom, 0.025 in the tail. Go to your t-table. 0.025 in the tail, 4 degrees of freedom is 2.776. So this is plus and minus 2.776. 0 in the middle, negative 2.776. So you got to put in here a plus and a minus to show me that you know it's a two-tailed test. All right, and you can see that our negative 3.87 is over here in the tail, right? Negative 2.776 is here, negative 3.87 is going to be over here. So we're in the tail, that's the can region. So can is the tail, cannot is the middle of the t distribution. So we're going to go down to our conclusion and say we can be 95% confident that dates and hours studying are linearly correlated. So that's part one. We found out there is a linear correlation. Step two is we're going to find out what that linear correlation is. And it's going to be an equation of a line. So it's going to have form y equals m times x plus b. Y equals mx plus b. Equation of a line. You've got to figure out what is m and what is b. Once you get m and b, you're going to write it in the answer right here. And you're also going to plot it on the graph up here. And it's got to be plotted very accurately. So this is kind of nice. Here's the formula for m. There's a big complicated formula on your formula sheet, but you don't need to know it because m is just going to be these two numbers divided by each other. So the top of the correlation coefficient formula and the first factor in the bottom of the correlation coefficient formula are going to be the slope of our line of best fit. So m is going to equal negative 60 over 80, which is negative 0.75. I will always make it come out evenly. You know, slope and y-intercept are always going to come out kind of nice. 0.75 is not perfect, but it's pretty easy to plot. So the equation of the line of best fit is negative 0.75x plus, and now we got to figure out what b is. So the formula for the slope is just the top of the correlation coefficient divided by the first factor in the bottom of the correlation coefficient. So you should write those numbers down. And down here, you just divide them, and I get the slope. Okay, so that goes right in here. B is a little bit more complicated. B, and this is on your formula sheet, it's called beta hat 0 on the formula sheet. Beta hat 0, and that's just because that's what statisticians, for some reason, call it. But you can just think of it as B, is equal to the sum of the y's divided by n minus the slope times the sum of the x's divided by n. Okay, so that's going to be 9 over 6 minus a negative 0.75. So be careful of that. It's minus a negative. It's going to become plus. Sum of the x's over n is 14 over n. 14 over 6. So you do that all in one step on your calculator. 9 divided by 6 plus 0.75 times 14 divided by 6. Don't hit equals until the very end. And that turns out to be 3.25. So the line of best fit is negative 0.75x plus 3.25. So that's the, out of the infinite number of lines that go through that we could draw on this graph, that's the one that best fits the data. Okay, so I expect you to plot that very accurately. So I'm going to start up here at 3.25, so that's right around there. And it goes down 0.75, so I would do it like this, 3.25 minus 0.75. That is going to give us 2.50. So my next dot is going to be right on the 1, x equals 1 line at 2.50. Subtract 0.75 again, and I get 1.75. So that's going to be down here. Now I'm over to the x equals 2 line, and I put a dot there at 1.75. I subtract 0.75 again, and I get 1. So now I'm all the way over at 3, right on the 1 y coordinate. Subtract 0.75 again, and now I'm to the 0.25. So now I'm all the way over here, right there, okay? And I just connect those dots with a straight line, and that's my line of best fit. That relates dates, which was the x-coordinate, to our studying, which was the y-coordinate. Okay, so we've magically, based on this data, come up with the line that best tells us the relationship between dates and studying. All right. Now you couldn't count up, this is just to kind of check yourself, how many points are above the line, how many points below the line. So let's do that. This point's above the line, this point's above the line, that point's above the line. So it looks like there's 3 points above the line and 1, 2, 3 points below the line. So that's normally turns out that way. There should be about the same above and below. If you get 5 above and 1 below, you may have made a mistake. So you're going to go back and check your answer. The last thing you need to plot on the graph, there's going to be 3 things you put on the graph. The data, the line of best fit, and then the centroid. Okay, so what is the centroid? The centroid is the average x and the average y. So it's this thing right here, sigma x divided by n. That's the average x, and sigma y divided by n. That's the average y. So I want to know what both those things are. So 14 over 6 is going to be the average x. That's 2.3. And 9 over 6 is the average y. That's 1.5. So you're going to plot that on my graph. So I'm going to go up to 1.5 and draw a line straight across. I'm going to go to 2.3333 and draw a line straight up. Where those 2 lines cross, I'm going to put a square right there. You also, and that square will always fall right on the line of best fit. If it doesn't, you've made a mistake. So it's a way to check yourself. And then also please label that x bar, y bar. Okay? So tell me, show me, okay, that's the centroid, and here I've labeled it so I know exactly what it is. So 3 things on the graph. Line of best fit, the data, and the centroid. And the line of best fit better go exactly through the middle of the centroid. Okay, last thing we're going to do, we're going to find a prediction interval around some particular x, and that's going to be x0. So in this case, I said find a 90% prediction interval for the number of hours studying by a guy that goes on 2 dates. So dates is x, so this is x0, 2. And part C, it says use the regression equation to predict how many hours a guy with 2 dates would study. So this, you're just going to take the 2 dates and plug it into the line of best fit equation. So I'm going to put 2 right in here, plus 3.25, and that's going to give me my predicted y. So negative 0.75 times 2 plus 3.25 is 1.75. And of course, we can see that right here. If I go up, if I go to 2 and I go up, I get to 1.75 on the line is right at, that's the y coordinate right there on that line, right? On the line of best fit, 1.75. So 2 is the x value, variable, the x value, and 1.75 is the y variable right there. Now what we're going to do is we're going to come up with some prediction interval around that. If I go on 2 dates, I probably won't study exactly 1.75 hours, but I should be able to come up with a 90% interval around that 1.75, within which I will, with 90% confidence, fall. Okay, I'll study, with 90% confidence between two values around that 1.75. So how you do that is two complicated formulas. One is the standard error of the error, SE, and that's the square root. This is on your formula sheet kind of halfway down. The sum of the y squareds minus b times the sum of the y's minus the slope times the sum of the xy's. Okay, and then that whole thing is divided by n minus 2, and then you take the square root. Make sure you do it in that order. So you just fill in all the numbers here. Sum of the y squareds is 23 minus 3.25 times the sum of the y's is 9 minus the slope, so that's going to be minus a negative 0.75. You're going to be adding that, times the sum of the xy's is 11. Divide that whole thing by degrees of freedom, which is 4, and take the square root of it. So 23 minus 3.25 times 9, and then minus a negative, so I'm going to go plus 0.75 times 11. This has to turn out positive. Is going to be 2. So this is going to be the square root of 2 over 4, which is the square root of 0.5, square root of a half, which is 707, 0.707. Okay? So that's the standard error of the error, which is 0.707. And now we plug that into the next formula, which is this crazy thing. Our t, no, my mistake. Our e, so this is the error, is going to be t alpha over 2 times se times the square root of 1 plus 1 over n plus n times x0 minus x bar, quantity squared, divided by, and that gives us crazy formula, but all you need to realize is it's the same formula as you used in the slope, the same formula as you used in the correlation coefficient. So you've already calculated that. In our case, it turned out to be 80, so I'm not even going to write the formula down there, and you shouldn't either. You should just use whatever you got out of your correlation coefficient, first factor in the denominator. Now remember that the slope has got to turn out to be an even number. So if you don't get an even number up here, a nice round number, then you've made a mistake, and you got to go back and figure out why it's not coming out exactly the way it should. Okay, so the error is going to be t alpha over 2. Well, let's see. This is the same as before. Degrees of freedom is 4, but now it's 90% confidence. So I've got 90% in the middle of the t table, 0.05 in each tail. So I'm going to look up 0.05 in the tail and 4 degrees of freedom, and I get a t value of 2.132. So what's going to go in here is 2.132, right? 90% in the middle, 0.05 in each tail, n minus 2 is 4 degrees of freedom, is plus or minus 2.132. SE, we just calculated, is 0.707. And then it's the square root of 1 plus 1 over 6 plus 6 times x0 is 2. That's the x value that we're predicting around, right? The x value we're predicting for, minus the average x we got from up above was 2.3333 squared, and then we're going to divide that whole thing by 80. Okay, so I'm going to do that all in my calculator. What's inside the radical? 1 plus 1 divided by 6 plus 6 times parentheses 2 minus 14 over 6. 14 divided by 6, close parentheses, square that parentheses, divide the whole thing by 80, And that turns out to be the square root of 1.175. Exactly. Okay, it works out exactly to be 1.175. I'm going to take the square root of that. So take the square root. Let me see where I put, if I can remember what I put, the 707. I'll just do square root of 1/2. So I take the square root of this times square root of 0.5 times 2.132. Can't type 132. Okay? And that's going to be my error, so I'm going to put that in memory. That's 1.634. So this number here, you know, it's going to be a prediction interval from 2 is going to be 1.75 plus or minus the error, which I got to be 1.634. So the error equals 1.634. So I'm going to take 1.75. I'm going to add 1.634 to it. And I get 3.38. So that's the upper limit. That's up here around somewhere. Let's see, where is that? About right here. No, it seems too vague. Let me think about that for a second. .38's right around here. And then 1.75 minus that number, 1.634, turns out to be 0.12. So 0.12, and that'll be down here someplace. So we're 90% confident that, you know, if I go on 2 dates, I'll study somewhere between 0.12 hours and 3.38 hours. So that's called a prediction interval. And it's a pretty wide interval because we only have 6 data points. So I didn't want to give you more data points than 6 because it would make it really hard to do the calculations. All right, one last thing, predict the number of dates of someone who studies 1 hour per night. So studying 1 hour per night, that's going to be the y coordinate, right? Hours studying is the y variable. So we're going to use our same equation. I'm going to put 1 in for the y coordinate, and now I'm going to solve for the x coordinate. So use the line of best fit where y is equal to 1, and I'm going to now solve for x. So I subtract 3.25 from both sides. So I have 1 minus 3.25, and that's negative 2.25 equals negative 0.75 times x. I divide both sides by negative 0.75, sorry. So divide by negative 0.75, and I get an x value of 3. So if someone studies an hour a night, they'd probably have gone on 3 dates. So that's just using the line of best fit equation backwards. Okay, so once you have that line of best fit, then I can ask you some questions about it so that you can use the relationship that you found to answer questions about. So that's an entire, you know, linear regression problem on one sheet. And there'll be a question like that on the test, you know, all those different parts to it. So practice it. Let me know if you have questions. We'll go over it Monday.